All right, so this is your examples video for lesson 21.1. And hopefully you have that worksheet done that I assigned you on Monday. So you want to keep that handy or in the background so you can easily access it as you're working these problems, because we'll be referring to it off and on. So we're going to start with problem number 3 on page 747. We're going to stick primarily to problems that use the formulas in this lesson and how to manipulate them. So number 3 says a flashlight bulb carries a current of 0.18 amps. How much time is required for 14 coulombs of charge to pass through the bulb? So think about what they're asking you to figure out. It says how much time. So you're looking for time. We are looking for time. We know that there are 14 coulombs of charge. And we also know that this bulb carries a current of 0.18 amps. So if you look at your worksheet that I gave you, on there I believe it says that current is the variable I, and charge is the variable Q, and T is the variable time. So what formula do we have? If you look at your list of formulas that uses I, Q, and T. So I believe we had a formula that said current was equal to the change in or amount of charge over the amount of time. And you're asked to figure out the time. So if you want to know time, that means you need to solve for t. So to solve for t, I would multiply both sides times delta t. And then to get that t by itself, I would divide by I. So if I do that, I end up with t equaling delta q over I. So in other words, I need to find time, I want to take the amount of charge, Q, and divide it by I, the amount of current. So if we do that, our charge is 14 coulombs, and our current is 0.18 amps. So if I divide those with a calculator, that should tell me the time. So if you divide those in your calculator, you should get 77.7 or 78 seconds. So 78 seconds would be your answer for number 3. All right, so this example is on page 749 in your book, and they have the answer to this one, but didn't really show you the numbers they used to get the answer. So let's go through this one. It says a battery with an EMF of 1.5 volts. So if you remember what EMF was, that was electromotive force, and it used the variable epsilon, which looks like this. It's a Greek letter epsilon, and so that's what the 1.5 volts is going to stand for. It said it delivers a current of 0.44 amps. So if you look back at your sheet that we filled in on Monday, current is the variable I. And to the flashlight for 64 seconds, so that of course is going to be time or delta time, amount of time. It says find the charge, so I'm looking for charge. Remember that charge was Q that passes through the circuit. And B, find the work done by the battery. So we're looking for Q and W. So part A, they tell you what formula to use, and it says I is equal to Q over T. That formula is on your sheet, maybe the first one, and I know that I'm looking for Q. So if you want to look for Q, you would have to multiply both sides by time. So if you multiply both sides by time, you would have I times delta T. So I know what I is. I is 0.44 amps. So 0.44 amps times the time, which is 64 seconds. So if you multiply those together, 64 times 0.44, that should round to 28 coulombs. All right, part B. Part B, they're asking you to find the work done by the battery. Well, here is the formula for work done by a battery. It's delta Q times epsilon. So delta Q, I figured out in the last problem, was 28. So I can use a 28 for my delta Q. And my epsilon was given to me in the problem. That's the electromotive force of 1.5 volts. So I'm going to take 28 times 1.5 to get my answer, which is going to come out to be 42 joules. All right, your next examples are on page 751, and they're referring to this formula here, which is the formula for voltage, which is, once again, in your sheet that we filled out on Monday. But voltage is equal to current times resistance, so I times R. And if you go down and look at this problem right here, they're this one's done for you. It says a potential difference of 24 volts is applied to a 150 omega resistor. How much current flows through the resistor? Well, it's important you understand what potential difference is. Potential difference is the definition of voltage. So when you see potential difference, that means voltage. A voltage of 24 volts is applied. So the V is going to be your 24 volts. So 24 volts, your resistor is 150 omegas. And so if I divide those two, that will give me 0.16 amps. All right, so let's look at 4 and 5. It says what voltage is required to produce a current of 0.62 amps in a 250 omega resistor. It even tells you you're going to use Ohm's law on this one, which is the V equals IR that we just seen above. So if we're using the formula V equals IR, and it says what voltage. That means I'm looking for V. I have a current of 0.62 amps. Remember the letter I stands for current, and R is for resistor, and right here is my resistor, 250 omegas. So V is equal to 0.62 amps times 250 omegas. So you multiply those together, and you will get your volts. And if you multiply those together, you'll get 155 volts as your answer. All right, let's look at problem number 5. It says when a potential difference of 18 volts is applied to the given wire, the wire conducts 0.35 amps of current. What is the resistance of the wire? And once again, you have to know that potential difference stands for applied voltage. That's pretty much the definition of voltage, and hopefully you have that in your definition section. So anyway, the 18 volts is going to go in for V. The current goes in for I, and you are looking for R. So if we have the formula V equals IR, and we want to solve it for R, that means we're going to have R equals V over I. Just simply divide both sides by I. And so if you take V, which is 18, and you divide it by I, which is 0.35, 18 divided by 0.35, you will get 51.4. And the units that you would put on that would be omega, because that was a resistor. It's the amount of resistance. All right. All right, now we're at the lesson check on page 757, and we're going to do problem number 12. It says resistor 1 has a resistance of 10 omegas and carries a current of 3 amps. Resistor 2 has a resistance of 5, I've been calling those omegas. I think I should be calling those gammas. I need to check on that. And carries a current of 10 amps. Which resistor has the greater potential difference? And so remember, potential difference is another phrase for voltage. So it's really saying which one has the greater voltage. And so we want to use Ohm's law again, which is V equals IR. Remember, I stands for current, R stands for resistance. So on resistor 1, so we'll call this V1 for voltage 1, current 1, resistor 1. And so to figure that out, I'm going to replace I with 10, or I'm sorry, I'm going to replace R with 10 and I with 3. So I've got 3 times 10. And for voltage 2, I'll use the second current times the second resistor. And this time we have 5 for our resistance and 10 for our current. So 10 times 5. And so the question is, which resistor has the greater potential difference, which means voltage? So out of those two, which has the bigger voltage? Well, this one's 50 and this one's 30. So the second one, resistor 2, has a larger voltage. So the answer would be the second resistor has a larger voltage. All right, moving on to number 13. All right, so for 13, it says you have a potential difference of 16 volts applied to a resistor whose resistance is 220 ohms. Ohms is the correct term for that. What is the current that flows through the resistor? So they're asking you to find current, which is the variable I. They give you resistance, which is R, and they give you voltage, also known as potential difference, of 16. So I'm going to use Ohm's law again. V equals IR, and they're asking you to find current, which is I, so you want to take V divided by R to find I. So your voltage is 16, and your resistance is 220. So if you take 16 divided by 220, you will get 0.073 amps. For number 13. Number 14. 14 says, what voltage is required to produce a current of 1.8 amps through a 140 omega resistor? So once again, Ohm's law, we're looking for voltage. Voltage is current times resistance. And my current is 1.8 amps. And my resistance is 140 omegas. So I multiply those two together to find my voltage. So this one will give me a voltage of 252. 252 volts. All right, so that's all of the examples I'm going to do for 21.1. Your problems are posted in Schoology for you to work.